Let's follow some lines. It was really important to start the project with a good pin layout. This allowed us to complete milestones in parallel with making a proto board that kept our wiring clean and organized.
Another cool feature of our robot was our proto board. All of our hardware was soldered to this proto board and made for really secure connections throughout the whole process.
We tried to keep the footprint of our robot as small as possible to make turning easier. This also helped us complete the tasks easier and kept our robot light.
Another cool part was a servo function in our code that translated an angle input to an OC1R value. That made changing the angle in our servo motor a lot easier.
Our QRD setup is fairly innovative. We use an extender to mount our QRDs.
Something I might have changed is using proximity sensors instead of QRDs for the line following, and using 3 instead of 2.
The photodiode is fairly simple. Just mounted onto a 3D printed bracket. I would also, as a side note in the future, add a part of the bracket to help better protect the photodiode.
One of the goals with the design was to have the QRDs far away from the stepper motors. That way we could have more fine-tuning adjustments for line following.
Throughout the entire design and building process, it was important to keep our code neat and organized. We kept our code easy to navigate and made sure to make a lot of comments so that we could understand each line while we were debugging.
One of our goals was to minimize pin usage. A way that we achieved this was to combine the laser pointer with the ball retrieval system.
Overall, this project required a lot of time and effort. We tried to be as innovative as we could as we worked. Although we didn't get the full amount of points during the competition, we still managed to build a functional robot and learn a lot of things along the way.